Hey guys, Clint and Jesse here from Vertek. Today we're going to talk about software tips and tricks. Let's jump right into it.
So today we're going to talk about how to process your seismic data that was collected during your CPT sounding. This process is essentially the same for our VTK series of equipment and our HT series of equipment. We're going to go through some steps on how to filter, enhance, and choose the correct arrival times based on the data that you collected. So let's jump right into it. You're going to open up your cone plot software. This is the same software you use to process your regular CPT soundings and dissipations. So when you're on the main screen here, you're just going to click on this button that says Process Seismic right down here. It's going to open up a new window and ask you what test you want to process. Unlike a regular sounding, you cannot batch process seismic tests. You can only process one seismic test at a time. So I have an example file here that has strikes taken on both sides, so an A and B strike, and then I have another one we'll do that's just a single strike. So let's start with this one. Okay, so we have our seismic test all loaded up here. You'll see all the various strikes numbered here on the left, and the depth that those strikes were taken shown here on the right. And for this test, like we talked about, there is an A and B strike. The A is represented by the red wave, and the B strike is represented by the blue wave. And the goal here is to clean up this data if needed and choose an appropriate arrival time for each depth. So what we're going to go ahead and do is go through these individually and start editing them and choosing our arrival time. So up here you can enhance all the graphs and filter all the graphs, trim them and so forth, remove strikes. But we're going to go through this individually for the first time. So to edit a particular depth, we're going to double click on this and it's going to bring up this new window. And this window will let us edit either the red wave or the blue wave and choose our arrival time based on the red wave and the blue wave. So if you look down here at the bottom, it will say arrival wave, and you can either select the red or the blue, and what that's going to do is it's going to bring up this little bullseye, and for instance we're on the blue wave, so it's going to follow that blue wave, and this is how we select our arrival time. Click on red wave, it does the same thing following the red wave. And on the upper right hand corner of the screen here where it says zoom, when you have your mouse hovered over the wave, you'll see kind of a zoomed in version, so it's easier to choose wherever your selected arrival time may be. Just to the right of this we have this adjust wave option, so you can either adjust the red wave or the blue wave. So for instance, if I have the red wave selected and I want to filter it, I can hold down this filter button and it will edit the red wave, or I can go to the blue wave, do the same thing, filter, or let's say I want to enhance it. You'll see the blue wave being modified and then red wave being modified. Another thing you can do is you can actually trim your test. So if you go to the top little header here, you can hit trim test. And for instance, this test was taken from 0 to 300 milliseconds. This is a time that's chosen when you're actually collecting the data. In CPT Sound, it will say how long of an interval do you want to collect data for. And if you watch our how to collect seismic data video, it will explain this a bit more. But essentially, whatever you took for data in CPT Sound is what's going to convert directly over to here. So in this case, 300 milliseconds is how long we recorded data for. The real chunk of the data that we're looking for is kind of from this section right here, from 0 to, let's say, where these waves kind of taper off. So let's say somewhere, around maybe 100 milliseconds or so. We could trim these. It's okay to not trim them as well if you want to look at it and kind of see the entire sound wave and how it tapers off. Sometimes it's easier to trim them if you're trying to really hone in on this specific area right here. You can trim them and it may help you look at the test a little bit easier. In this case, we're not going to trim them because these are just fine to process the way they are for now. So I'm going to hit cancel on that. If we wanted to just look at one wave, we could always hit remove wave and you could remove the red wave, which is the A wave, or the B wave, which is the blue wave. But if you do that, you're probably going to want to do that for each and every test. So for instance, I wouldn't remove a red wave on this test and keep it on the next test, and then have both red waves on the following test and then remove it for the next test or something. I would keep all tests with both waves if that's how you plan on editing your data and processing it, or I would eliminate all the blue waves or all the red waves for this entire seismic test, not just this one particular depth that these strikes were taken at. Okay, so let's talk about choosing your arrival time and kind of what the sound wave should look like. If you look at this, you see this kind of flat line here in the beginning where there's really no sort of sound wave or seismic waves showing up. And then all of a sudden you can see where it kind of increases in size here on both the red wave and the blue wave. And that big sort of increase in wave size is what I would call the arrival time for this wave. You can choose a different point than I'm going to where you want to say that this wave arrived, as long as you choose the same point on the wave on every single test. By that I mean, I might say, okay, this sound wave, I'm going to say the arrival time was this big valley right here. And that's fine, but if I go to the next test, I'm going to choose that same valley right here. So what you can't do, I'm going to reset that. So what you can't do is choose the valley here and say, okay, the sound wave looks like it arrived, and I'm going to choose this point right here, and then the next test be like, okay, I think it was the peak right here. You have to choose all valleys, all peaks, maybe all intersecting points. It doesn't really matter as long as you're choosing the same spot on every single test. So let me reset this arrival and go back to the first depth here. So before I actually choose this arrival time, I'm going to hit reset arrival, and I'm going to look at all of these tests. So I think there's somewhere around maybe 30 or 40 tests here. And let's just go through and look at all of these and see if we find that one sound wave looks better than the other, because you may say, hey, this red wave has some clipping on it, or it got really noisy as we got deeper in the ground. You may say, let's not use the red wave for our arrival times, let's use the blue wave. So even though it may look good between 2 meters and 11 meters, when you get down to say 30, 40, 50 meters, that sound wave may look kind of poor, and we probably don't want to choose that to have consistent arrival times. So I'm going to hit this button here that says return to main seismic. What that's going to do is bring us just back to this kind of waterfall table here that we're looking at. And I'm going to scroll down the list, and you can see these sound waves here. And as you increase your depth, you should be increasing the amount of time it takes for the sound wave to arrive. So let's go all the way down to the bottom here. These are a bit hard to read like this, so I'm going to double click on the sound wave and take a look at it. I'm actually going to enhance both of these a little bit just so they're easier to see. And so this data looks pretty good. And how I know is I'm looking at this nice flat line that has very little noise or static on it. You can kind of see the red wave has a very little bit of noise. If you look at the kind of upper right hand side crosshair zoom section of the screen, you can see how the blue wave is very, very flat. The red wave has just a very little bit of noise on it, but overall both waves look really, really good, especially for, this is a 26 meter interval right here. So I'm going to look at both of these and say, okay, the red wave and the blue wave looks good. So we could choose this intersection point right here as our arrival time throughout the entire test, but let's look at a few more and just make sure that it's good. So I'm going to hit return to main seismic. I'm just going to choose one, maybe 5 tests up. I'm going to double click on it, look at this one. I'm going to enhance both of these waves a little bit. So I'm going to click here on adjust wave, adjust the red one, adjust the blue one. I'm going to say both of these still look really good. So let's go back to main seismic screen here. Just go up a little farther. All these still look really good. So let's go ahead and start choosing some arrival times. So based on the fact that both of these waves look very good, they look really consistent throughout the whole entire test, you don't really have any noise, I'm going to choose the intersection point as my arrival time. This is a fairly common practice if you're looking at both A and B strikes, so a left strike and a right strike, or in this case it looks like a blue wave and a red wave. It's not uncommon to choose this kind of intersection point. And again, the most important part is to make sure you're choosing the same intersection point on every single test. So I kind of chose my intersection point roughly where it is. Granted, it's hard to see here, so I'm going to use this left and right toggle button here and dial this into exactly that intersection point right here. Then I'm going to go to the next test. I'm going to hit this button here. It says next test, and choose that same kind of intersection point on this one. And then I can hit the left arrow here and dial this in to be right at the intersection point. And if you have a hard time seeing that when you're looking at this kind of enlarged screen, you can hit this button that says hide reference wave, and it will actually make the previous wave go away. Sometimes it's helpful to have that previous reference wave behind you to see the old arrival time that you chose, to make sure you're choosing a consistent intersection point. But in this case, it's a little easier to see it if I hide the reference wave and I just look over here on the left and say, okay, I chose the intersecting point where the red wave is descending and the blue wave is ascending, and then I chose the same thing here on test number 2. So I'm going to go through and do test number 3 and do the same thing. So I'm going to hit next test. Here's test number 3. And like I said before, the arrival times that we're choosing are where the red wave is descending and the blue wave is ascending. So I'm going to choose somewhere right around here, and then I'm going to dial this in. To that intersection point. And let's go to the next test. I'm going to choose that intersection point again. Remember, it's where the red wave is descending and the blue wave is ascending. And again, you could have chose a different point, like maybe where this red wave is ascending and the blue wave is descending. But if you did, you would have to choose that same sort of arrival point on every single wave. So what I'm going to do is just go through all of these and choose that arrival time. And as I do this, if you look over on the right hand side of the screen, you will see that I'm getting velocities here. So it's saying what my arrival time is. So for instance, this one right here says 17.24 milliseconds. My velocity is 175.6 meters per second. And the next depth gives me a velocity and arrival time and so forth. So let's work on editing this. This is a pretty clean looking sound wave, so there's not much editing to be done. But if this had a lot of staticky, kind of noise on it, and it was hard to choose an arrival time, the best thing I can say is don't be afraid to filter and enhance each sound wave. When you filter and enhance, it's not going to actually shift your arrival time left or right. So basically increase or decrease the amount of time it took for the sound wave to arrive. All it is doing is just cleaning the wave up and then amplifying it so it's easier to choose that arrival time. So for instance, if my arrival time, I'm going to choose this intersecting point here, I can enhance this and then also enhance the blue wave, filter it if I need to, right? So I have this filter button down. You can either do single clicks on it or you can hold it down and then click on the red wave, do the same thing, filter that. Again, there's not much filtering happening because the wave already looks very, very clean. Right, but then I could go like this and choose that same arrival time. So I'm just going to keep going through here and choosing all of my arrival times, filtering and enhancing the data as needed. Again, these are all very clean. it doesn't look like any of these need to be filtered or enhanced because these are all very good looking sound waves. And I'm not going to go through and choose all 30 of these arrival times while I'm making this video for you. So I'm going to stop right here and hit return to main seismic. And you will see all these arrival times that I've chosen. And as you can see, they start very close to 0 milliseconds and work their way up as you go deeper in the ground, which is exactly what it should do. And you'll see all of our velocities here based on those arrival times. And if I was happy with this, I would just hit File, and then you can either save this if you want to just save this process data, which will essentially save the file just how it looks right now, or you can also hit Export Data, and you can export this to text file, CSV file, in case you wanted to put this in a third-party software. You can also click Generate Profile and create an arrival or velocity profile. And these are very commonly used to add to a CPT sounding file. So for instance, I could click velocity. It's asking me if I still want to continue because I have not chosen all my arrival times, so it doesn't have velocities for every single depth. In this case, I'm going to hit yes because we don't need to go through and choose all 30 arrival times just for this video. So then I would just name this test. I can name this example file velocity, and you'll see the file type here is saved as a .vss. So when you create a velocity profile, it changes the file type name to be represented as a velocity profile. So I just hit save, and then this data would be saved just how you see it. And then you can actually take this data and input that velocity profile into your CPT sounding file, and it will show up with all of your data points shown with the velocities next to it. Okay, let's go ahead and edit one and process one that only has a single strike. So in case you don't have two strike plates. So I'm going to hit return, I'm going to hit process seismic, and then I'm going to process this example file here. So a lot of users who have, say, drill rigs or S4s may only have one strike plate, and this is a prime example of what your sound wave would look like with just one strike plate. So as you can see, there's just a red wave, which is your A strike. There's no blue waves on here. And this data also looks very good. Shows the number of strikes here on the left. So strike 1, 2, 3, 4, 5, and your depths 4 meters, 5 meters, 6 meters, 7 meters, 8 meters, all the way down to 17 meters. So let's just go ahead and choose some arrival times on this one. When I'm choosing my arrival times, I kind of like to look at this waterfall here and say, okay, what point am I going to choose? Because let's say, for instance, you were to just look at this first test and say, I'm going to choose this little peak right here on test number 1. And then you look at the peak right here on test number 2 and test number 3, and that peak kind of changes in size and then it eventually kind of goes away. So that would be a poor decision to choose that point, because as you go deeper in the ground, that first kind of initial sound wave that you see goes away. So you could choose this valley right here, because if you look, that stays pretty consistent throughout each test. You have a nice kind of amplification of it. It does tend to kind of taper off a little bit. So in that case, I'm going to choose this first peak that I see, because it seems to have the most kind of consistent profile throughout this entire test. As I scroll down, see this peak kind of stays nice and consistent. And you could go all the way over here and choose this peak if you wanted to, but same thing. This is less amplified because this is kind of the initial sound wave. So as you can tell, this peak kind of tapers off and falls away. So in this case, I feel that this peak right here is the best spot to choose. So again, I'm going to double click on this and then choose my arrival wave. In this case, we only have the option to choose a red wave. So I'm going to hover my mouse over this first big peak that we talked about and adjust this so that I am basically right at the crown of the peak, and then go to the next test and do the same thing. So a couple minutes ago, I talked about having a hard time seeing the data with the reference wave on the same page. In this case, it's not very hard to see the data because we're only looking at one strike, so there's not 4 waves total on the screen, there's only 2. And I actually like when I only have, all red strikes or all blue strikes, for instance, having one sound wave. It's really nice to have that reference wave because you can really tell exactly that point that you picked on the last test, and you can make sure that you're choosing the exact same point per test. So I'm just going to go through and choose these real quick. And as you can see, every point that I choose, it's creating a arrival time and a velocity here over on the right hand side. I'm not going to go ahead and pick all 20 points on this test just for this video, but let me show you real quick a couple other things. So we have this edit all button up here, and this is where you can again enhance and filter and whatnot all the graphs. So I'm going to click on enhance all graphs, and by doing that it's going to kind of increase the amplification of every single one. And then if I were to hit filter all graphs, it's going to filter all these graphs just a little bit. Granted, this data looks very, very clean, so when I hit the filter button, you don't see a lot of filtering happen, but it does take away some of that kind of noise and static that you see on that sound wave. And then you can hit remove strikes, and for instance, if I had taken a B strike as well at every single depth, I could click remove B strike, and that would remove all those. In this case, I don't want to remove any A strikes because the whole test is just A strikes. So if I were to click this, we'd have no data left. Another thing to mention is that let's say there is one strike that just doesn't look quite right because maybe your strike plate didn't have enough weight on it and it's just too hard to interpret the data for that particular depth. You can actually remove that wave off the list. So let's say, for instance, that this one right here, test number 6, which is at 9 meters, let's pretend like this data looks really poor and we want to get rid of this sound wave. So I can actually click on this, and then I can hit remove wave and remove this particular A strike. So I hit remove wave, and that one is gone off my list. So I hit return to main seismic, and now you'll see test number 6, instead of being 9 meters, it's now 10 meters, and it shifted all those tests up. That's really handy if you have a particular wave that you can't really cipher out and choose an arrival time on. I'm of the opinion that it's probably better, if you can't choose an arrival time, it's probably better to discard of that one particular strike than it is to keep it and just take a wild guess. If you can't properly choose an arrival time, just choosing any random point is not beneficial to your data, and you're better off just to eliminate that strike. Okay, so let's say we were done with this test. I would do the same thing as I did before. I'd hit File, Save. You can actually print it as well. You can export the data as mentioned earlier, and you can generate your profile. So in this case, let's generate an arrival profile. And it's going to ask me the same question. It says, not all delays have been determined. Do you want to continue? Which is basically saying, hey, you didn't choose all your arrival times. And I'm going to click yes, and I'm going to name this example arrival file. And you'll see the file type is changed once again. So the velocity was a .vss file, and this being a arrival file is a .dly. So you can do the same thing with this as you can with a velocity profile. You can actually create both and import both of these into your CPT sounding. So you just hit save and then click return, and it will bring you back to your main screen. So the last thing I want to show you is how to add your velocity profile to your sounding. So I'm going to click on process sounding, and I'm going to choose a test. And just keep in mind that the test that I'm choosing doesn't actually line up with the seismic test that we took, so the data may not match whatsoever, but we're just doing this for training purposes. So I'm going to choose this test right here, Rugby Bridge 006. Click open. I'm going to choose, say, tip, sleeve, and pore pressure, and then I'll click this button up here that says add data, and go back to my desktop where I saved those other files, and I'm going to choose, let's say, this velocity file. So I go to this velocity file, I'm going to hit open, and down here at my list there's going to be a new option that says seismic velocity. So when I click on seismic velocity, you can now plot this data, and you'll see your CPT data here, and then see the seismic velocity right here. It will show you basically for every meter that we took a test, it will show you what the velocity is. And typically you'd see the velocity kind of line up with your tip pressure, right? So a higher tip pressure probably means a little bit faster soil, so a higher velocity, right? Because the soil is probably stiffer. And then a lower tip pressure, you may see a lower velocity. Again, this one doesn't really match up because they're both not taken at the same site, I don't believe. But that is how you add your seismic profile to your CPT sounding. So that's really it. That's how you process your seismic data. If you have any questions, feel free to give us a call or send us an email or check out our website, www.vertekcpt.com. We'll see you at the next video.